In section 1.4, we have practiced simplifying radicals and working with complex numbers. In this video, we're going to put those skills together and simplify more complicated radical expressions. These radical expressions will be similar to the results we get later when we solve quadratic equations with the quadratic formula. So it's important now that we understand how to work the arithmetic, so we'll be ready for the algebra later. On example 7, we want to simplify the following expressions completely. Rationalize the denominator where necessary. On example A, we have negative 8 minus the square root of 128 divided by 4. Now, the first thing I want to do is work on simplifying the square root of 128. So I'm going to do that as side work. Let's take 128 and rewrite it as a product of a perfect square and some other factor. Notice you can write 128 as 64 times 2. When we split up the radical over each factor, we have the square root of 64 times the square root of 2. And that can be simplified as 8 square root of 2. So I'm going to take this result and replace that complicated square root of 128 on my next step here. So we have negative 8 minus square root of 128 simplifies as 8 square root of 2, and we still have a 4 in the denominator. As we've been doing with complex numbers, we can split this fraction into two terms by taking the first term in the numerator over the denominator minus the second term from the numerator over the same denominator. We can then reduce each term. Negative 8 divided by 4 gives me negative 2. And over here, I can cancel the 4 into the 8, but I can't cancel the 4 with the radicand, by the way. So when we reduce, we end up with 2 square root of 2. So our answer is irrational, negative 2 minus 2 square root of 2. Let's see how the calculator is going to handle this one. I want to type in the original problem. Notice the difference between the negative sign in the calculator, that's the button at the bottom with the parentheses, and the minus operation in the operation keys on the right side of your keypad. So we have square root of 128 and in the bottom 4. Now, because this is an irrational number, the calculator is going to give me the decimal approximation. I don't want to report that as my answer unless I need the approximation for some reason. I want to keep my answer exact. So I'm going to type in what we came up with, negative 2 minus 2 square root of 2. And notice the decimal approximation from the calculator matches the original answer. So even though I'm not after the approximation here, I can use it to check my answer. Let's try the next example. 16 minus the square root of negative 64 divided by 24. Now, again, I want to start by simplifying this radical. Well, 64 is a perfect square. And you know the square root of 64 is 8. But when we have a negative under the radical, that represents an imaginary number. So we can simplify the square root of negative 64 as 8i. Notice the negative here between the two terms appears right here, and the negative under the radical is now disguised in that I. And in the denominator, we have 24. Because this is a complex number, we have to write it in the standard form a plus bi. That is real part separate from imaginary part. So I'm going to split up my fraction again, each term of the numerator placed over the denominator, and then we can reduce. The common factor between 16 and 24 is 8. 16 divided by 8 is 2, and 24 divided by 8 is 3. The common factor between 8 and 24 in the second fraction is 8. 8 divided by 8 is 1, and 24 divided by 8 is 3. So we end up with 2/3 minus 1/3 times I. Let's double check this with the calculator. Typing in our original problem, we have 16 minus the square root of negative 64 divided by 24. Remember, your calculator needs to be in complex mode in order for it to correctly simplify square root of negative 64. And we have 2/3 minus 1/3 I. So we did a good job. Okay, our last example, we have, notice, a radical in the denominator. So we're not only going to need to take care of that, but also observe it's a complex number in the denominator. Let's start by simplifying square root of -4. So I'm going to copy the 3 from the denominator. This negative doesn't change, and this negative basically gets eaten by the I. So we have 1 over 3 minus 2i. Technically, we have a radical in the denominator, so we need to rationalize the denominator. So I'm going to take my answer, 1 over 3 minus 2i, and apply the complex conjugate, 3 plus 2i, to the top and the bottom. Adding parentheses for guidance. The numerator is simply 1 times 3 plus 2i, which we can call 3 plus 2i, and we can FOIL the denominator. The product of our first two terms, 3 times 3 gives us 9. Remember, with conjugates, the outside and inside terms cancel, and then we have the product of our last terms, negative 2i times 2i, and that gives us 4i squared. Replacing the I squared here with -1 changes ultimately the sign between the two terms in the bottom. So we end up with 3 plus 2i over 9 plus 4. Continuing to simplify, we have 3 plus 2i over 13. All right, that's pretty good, but it's not in an acceptable form. Remember, it must be in standard form. So we're going to separate the real part from the imaginary part. So you can write it like that, or you can put the I in the middle, 2 over 13 times I. And that one you could certainly check with your calculator. Although these problems may seem random at this point, this pattern of problem that we're working again is going to show up when we study the quadratic formula, when we're solving quadratic equations. So we want to make sure and have all this arithmetic mastered by the time we layer on top of that the algebra. So practice and study hard.